Hmm. All right. Welcome to the past. I'm talking to the future, right? Because I'm recording on the 16th for my classes on the 17th because, like I said, I had those appointments that I could not schedule in any way, shape, or form. So thank you for just having the patience and watching the recorded lecture. Not much is going to be different. You just can't comment and talk to me in the chat live. You can, of course, email me any questions after you watch the lecture if you have them. There's nothing wrong with that. Usual due dates and such. As a reminder, make sure that you do that addition or multiplication table, whichever you prefer, to prep for the Excel BMI homework, the 1.8 that's going to be next on the list after TV Learn. Your My Math Lab homework for 1.3 is due on the 17th. Your homework for 2.1, we will finish 2.1 today. On the 17th today, that's what I mean. We'll be able to do on the 24th. And 2.2, I have this as the 26th. Let's see how far we get. I don't think I'll finish, but let's see. If I do finish it today in the hour that I have, then we'll change that to the 24th. Your Excel TV Learn is due on the 17th. Your next Excel assignment is a week after that, that BMI, the one that you should make a multiplication table for to understand how to use fixed cell references, those cash symbols in front of a letter or in front of a number that we've discussed numerous times in class. So that's due on the 26th. And your first video quiz is located in Canvas. There is a location for you to download it. There is a location for you to submit it. In fact, let's do this. If any of you email me asking me where it is, I'm going to say watch the lecture. Let's just go in my first class. Quizzes. Download video quiz 1 here. So that's where you'll go to download it. And then once you type it up or handwrite it, you'll click here to submit it. That's all you got to do. You won't see a bunch of those other quizzes under it that are hidden. That's for future reference. Some we will do, some we won't. I change things every semester. So there are 4 questions, I believe, and they are based on the videos. So when I give you a video quiz, it's not you have to make a video of yourself or watch a video that I've done. It's you're watching the author's video. So you're going to My Math Lab, you're going to the video resource library, and I've already taught you how to get to the rest from there. So in that quiz, I tell you which videos to watch. And they are referencing the Excel videos because what are we going to struggle with the most? Probably Excel. So it's good to be reminded that there are other videos. I've already referenced them 2 or 3 times already, so this is either the 3rd or 4th. Use them. So it's going to be important. You need to be answering in sentences. If you feel like you need a paragraph, that's fine. A lot of people like to try and just copy paste word for word what the author says. I don't like that. I'm not saying I won't give you full credit for it. I'm saying I don't like it because copy pasting exactly what an author says does not demonstrate that you understand what it means necessarily. It may not. So again, if you did copy paste what the author said exactly, I would count it right. But I'd like people to use their own words when they can to make sure I understand that you understand. Because what can happen is people will copy paste something the author said and it wasn't the answer. It might have nothing to do with the answer, or it may have been the opposite of the answer because he's talking about a bunch of different things in a video. So I have times when someone copy pastes what he says and they get it right, times when they get it wrong because they clearly didn't understand what the question was asking. So read the questions, pay attention, you know the drill. You might be able to answer 1 or 2 of these with a single word or just a couple words. I'm not looking for sentence structure and paragraph. I'm not checking for spelling. Please spell correctly. You can type it up, which I prefer. You can handwrite it and submit a picture. It's up to you. Again, I really prefer typed answers for this, but if you have no choice but to handwrite them, take a picture and upload that way. I do believe I made JPEGs and the whatnot acceptable. The deadline is Tuesday, the 21st. I don't know why I didn't have that due in there. So that's due on 9/21. I'm sorry, 9/22. I'm looking at Wednesday's date and adding 5. 9/22 by midnight. I have to grade these by hand. I've got several classes that I'll have to do this for by hand, so don't expect the grade back immediately. It'll probably be 3 or 4 or 5 days. If a week goes by and I haven't graded it, that's because I had 10 million other things going on and I forgot. Just hopefully someone emails me and says, hey, what's my quiz 1 grade? Oh, sorry. Do not submit these late. I will not take late submissions. You're supposed to be following this stuff in a timely fashion. Because of the format of everything today, and I am really scraping things together at the last second, unfortunately, because of, again, appointments and some other things that happened. I have a giant hole in my ceiling right now that we don't need to talk about. But I'm not going to do a discussion board. Just make sure the stuff that I do that would have been from a discussion board today, that you are able to follow along with it. Try and reproduce it on your own. That would be a really good idea. I'm going to be the master discussion board, essentially, for a couple of the questions I had. So yeah, where we left off. We had done this. We talked about how we can use proportion or ratio tables to find out anything, as long as we know that the table is set up in a proportional manner. Just because you have a table of numbers doesn't mean it's proportional. Someone has to tell you that, or you have to establish it based on patterns and things like that. And the main pattern is whenever one thing doubles, the other doubles. You could say it as one triples, the other triples, as one quadruples, the other quadruples, but proportional means a constant multiplier between them. Just like 2 apples triples to 6 apples, the 3 oranges triple to 9 oranges. If this, it may be on Wednesday, there were 10 apples sold, that means they sold 5 times as many apples, which means they'd sell 5 times as many oranges. Now, does a store's apples and orange sales have to be proportional in the real world? Absolutely not. They could actually be what's known as inversely proportional if maybe there's a sale on one of these things, so people are going to buy way more apples than oranges, or vice versa, whichever one's on sale. So again, in the real world, you might have to put your brain cells together and figure out whether they are proportional or not, and then extrapolate from there. But we said the wonderful thing about a proportion table is that they don't have to be all just sitting next to each other to set up the fraction equal to a fraction and cross multiply. There can be giant gaps between them, and very often they are in the problems that we have to do. But it doesn't matter. You don't need any of the numbers in between, as long as you can imagine yourself drawing a box around some numbers. And when you do that, you have 3 corners of numbers and a blank. And it doesn't have to be the bottom right blank. There could be a number here and the top left is blank. You just set fraction equal to a fraction. We've discussed the 10 different ways. I mean, rounded number, the 8 different ways you could set it up. It could have been 2 over 3 equals 6 over x. It could have been 2 over 6 equals 3 over x. It could have been 6 over 2 equals x over 3. It could have been 6 over x equals 2 over 3. It could have been x over 3 equals 6 over 2. It could have been x over 6 equals 3 over 2. I mean, I don't even know how many ways I just said in that lightning bolt amount of time. But all of those would have led to the same answer of x equals 9, which in this table, it was limes on Friday. Whereas before, the smaller table, different fruits, different days, just to prove a point. Again, you will see this over and over in this course, especially with something called a consumer price index. We'll get into that later. So what we did from there is we pulled up our guided worksheet, and we were talking about how, okay, we have some births based on a population. We said maybe we shouldn't base it off of the whole population, maybe just the number of women in birthing age. We wanted to find out how many births there would be if there was only a population of 1,000 people. This is scaling. It's not scaling to 1, it's scaling to 1,000. We could also say that there's 60.2 births for every 1,000 women of birthing age. So that's another scaling. You can use that idea to go back and find out how many birthing aged women there are. What we did together last time was we used these simpler numbers of 4, 8, 12, 8 ended up being there, 500, 1,000, and et cetera, whatever number that happens to be. Whatever off the top of my head, that's okay. So what we're going to do this time is use the more legit numbers with these ugly decimals, et cetera, not decimals, just millions and millions, and we'll have decimal numbers. They say to round to 2 decimal places. Remember, you have to pay attention to this. My math lab marks things wrong when you round wrong. Round to 1 decimal, it's wrong. You round to 3 decimals, it's wrong. Maybe on a test, if you showed some work and mentioned it to me, I can give you partial credit. So I said maybe. If you didn't show your work, no partial credit. Now, do you have to have an entire page of work to get partial credit? No, I just have to see something. Otherwise, I can't say, well, you didn't prove that you actually figured this out in any way, shape, or form, so maybe just pull the answer off the internet. I don't know. That's not the point of quantitative reasoning. You can use the internet as a resource, but not to do the answer. Okay, so this is in a proportion table. They said everything was based on proportions. So our goal is to find the B and the W. And they give you some space to fill out the work. I don't like using the annotation that way, as you have seen multiple times. So let's just do the work over here. Now, move this a little more because I can't see all the numbers. Good enough. Numbers and variables, that is to say. So they called B for births. Now this B is specifically representing when the population is 1,000. So this B is the number of births per 1,000 people. 1,000 people. And the W would be the number of women of birthing age in the total population. So you've got to pay attention to your rows and columns and how things set up. Everything is relative. This B isn't based on the whole population. It's based on if the population was only 1,000. So it's scaled. So we talked about how scaling things to 1 or 100 or 1,000 can give us sometimes prettier numbers, sometimes easier numbers to relate to. Like if you scale something to 100, you can think of it as a percentage. Population things are very often scaled to 1,000, just to kind of eliminate 3 places, if you will. Yeah. So imagine yourself drawing a box in such a way that you'll have 3 numbers and a variable in the corners. So just really quickly, if you do like this is not going to solve for the B. First of all, the B isn't in a corner. And you got 3 numbers in corners, it would actually solve for this right here. If you use this number, and this number, you could go 3.8 million over 60.2 equals 324 million over X. But I was not asked to find the population if there's only 1,000 women of birthing age. So again, scaling down the population. We weren't asked to find that. Don't find that. Can you find it? Yes. Would you have maybe a job that makes you find all of these blanks? Maybe. Is that our goal? No. We're only finding these 2 specific things. The number of births per 1,000 people and the number of women of birthing age. So don't do more than you have to. We're just going to do this as our box. So the 3.8 million over the B equals the 324 million over the 1,000. All right, so 3, and I'm going to abbreviate, come on, don't do this to me today, 3.8 million over the B is equal to the 324 million. Now when I do my calculator, I will write the numbers in appropriately. You cross multiply, so you'll get 3.8 million times 1,000 is equal to 324 million times the B. Again, the M's are abbreviations for millions. Don't think they're variables, please. 3.8 million times 1,000 is just going to make that billions, so it's now 3.8 billion. I'll write the word because there's another B. So in other words, it's just 3 more zeros on this number right here, 472,000. That'll be equal to the 324 million number times the B. How do you solve that very simple equation? You divide both sides by the number with the variable, 324 million. And that tells us that B is equal to, let's pull out our calculator. So 3,853, let me clear all that stuff. That was from my other class earlier. 3,853, 4,3853472,000 divided by that 324 million number, which is 324,459,463. And we get 11.87, blah, 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 blah. We're rounding to 2 decimals, so 11.88. Don't forget, when quantitative reasoning, make sure you understand what exactly you're answering. Don't just give this number. This is not the answer. The answer is, so it's 11.88 births, because that's where we were births, and then it's based on a population of 1,000 people per 1,000 people. That's what's happening there. That's what that number means. It's 3.8 million births per 324 million in population. It's about 12 births per 1,000 people in population. If our births was 60.2, again, we could figure out what that x was some way, shape, or form. I've already described, but we weren't asked to. It's not really an important number, so we don't. The next thing we were tasked with finding was this w. So if we try and draw a box, now you could certainly do this. I'm going to say I'm not going to, but you could. You could draw your box this way, because then you've got number. We now know this number. Wait, we don't know that number over there. Excuse me, I'm thinking that I had the number there. So we can't. I'm going to say that didn't make sense to myself like we do with quantitative reasoning. I caught myself and I said, there's no number here, there's no number here. So that's two numbers and two blanks. But the point of me bringing this up was, this right here, this b, was rounded. So this 11.88 is a rounded number. If you use a rounded number to find another one in a proportion table, this is going to have something called error truncation or error propagation. You use a number that's been rounded to find another answer, and then round that, and then use that to find another answer, and then round that. These rounding errors end up causing bigger errors down the line. So maybe this answer is supposed to be, let's just say it was 12.5. That's completely wrong, but it's supposed to be 12.5. But with your number, you get 12.6. My math lab might mark it wrong, and that's because you used borrowed information to move along. So my suggestion is to try and only use, when you can, the numbers prescribed to you. I guess I could have just hit clear. There we go. So we know this is the end of it, so I got to draw the box that way. Now you might say, okay, can I do it this way? Can I do it this way? Can I do it this way? Well, no. Number, number, blank, blank. So that fails. Clear. Maybe we need to go down all the way. Could I do it like this? No, because there's a blank here and a blank here, so that fails. But if you do it across the whole entire table, excluding labels, remember labels are not numbers in a proportion table, they're just labels. We got number, 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 and the variable. So there is what we need to draw up. All right, but I do have to clear that. Come off of annotate. Scroll down. So that would be, I'll do it in a different color. We'll do black this time. 3.8, the million number, over the 60.2. Remember, it's this number over this one. This is the easiest setup in my opinion. Equals the W over 1,000. We cross multiply. We'll get the 3.8 million times the 1,000 equal to 60.2 times the W, which is 3.8 billion equal to the 60.2 times the number of women of birthing age. Divide both sides by 60.2. If you can't do this very simple algebra, you have got to practice it 1,000 times before you can. And then do the calculation. So the 3, 8, 5, 3, 4, 7, 2. And then there was the 3 more zeros from multiplying it by 1,000. And we're dividing it by 60.2. And we get 6401162.79. Now, they said to round to the nearest 2 decimal places, so that says that W is equal to 6. Wrong color. 6401162.79. Actually, our calculator, because it can only handle so many numbers, went ahead and rounded it to 2 decimal places for us. But what exactly is this? This is women of birthing age. Now, very often when we're talking about a large number of people, we don't really like decimals. If we're talking about a couple of people, like, hey, the average household is 4.2 people or something like that, that's when we'll leave a decimal with people. But it's really hard to have 79/100ths of a person. So the rule of large numbers kind of states that you just round that to the nearest whole instead. So 6401163, which would be 64,011,163. I knew my comma placement wasn't perfect there. let me just rewrite the number. I can do better than that. 64,011,163 women of birthing age. That's the answer. It's not 64 million people, 64 million women of birthing age. Remember, you're supposed to be doing these and then asking yourself if it makes sense. Well, if the population is 324 million, does it make sense there's about 64 million women of birthing age? Well, about half the population is women, so half of 320 million is about 160 million. And there are women younger than 15. And the biggest portion of the population is the people under 21. So there's a lot of women under 15, girls, whatever you want to call them. I don't care about labels. And then there's a decent amount of women over 44 as well. So I'd say this is a pretty good ballpark answer. What do I mean by does it make sense? How do I really say this number makes sense? What if I forgot to multiply by those zeros and I said the answer was 64,011? What's going on? If I said the answer was 64,011 women of birthing age, would that make sense? Well, if there's 324 million people we're discussing this relative to, I don't think 64,000 women of those people are able to give birth. It's way more than that. That answer would not make sense. Or maybe I had too many places. Maybe I said that there were 640 million women. How would there be 324 people on the world, or in our country, excuse me, in our country? How would there be 324 million people in total, but there's 640 million women able to give birth? That's more than the population. That wouldn't make sense. You have got to learn to do that after every single answer of anything in a quantitative reasoning sense, which is pretty much the entirety of this class. All right, so next up, what we're going to do is that far enough over? Yeah, that's far enough over. Okay. So the next thing we're going to do is we're going to talk about college tuition, because what do we all pay, or someone pays for us? College tuition, right? So they have a column for private four-year schools, which are historically the most expensive. They have a column for public four-year schools, traditionally the in-between. And then they have a column for the public two-year school. So the left is our private schools, oh man, what is the local one? I'm blanking. Let me come back to it. Then we have our public schools like ODU, Virginia Wesleyan. There we go. Now I remember. So private four-year, this is kind of like our Virginia Wesleyan, but averaged across all of them. This middle one's like our ODUs and our Norfolk States and our VCUs and our Virginia Techs and UVAs. Then this right column is our TCCs and our Thomas Nelsons and all the other ones like that. So our community colleges are the cheapest by far. Our ODUs and CNUs in Norfolk States are kind of middle of the road. And our private schools that are not governmentally funded, so since Uncle Sam's not helping with the bill, you got to pay the whole thing, $30,000. So they're saying these were the average tuition and fees across a whole bunch of different places. In 2013 and 14, these numbers have gone way up, like tuition does. But that's okay. Old numbers are fine to understand. So what's going on with this table? What's this 1 right here? What's this 100 right here? What's this 1 right here? Ignore this multiply bit for a second. I've already alluded to that earlier when I was talking about apples and oranges. All right, 2 apples on Monday, and then it's 10 apples on Wednesday. So that was a multiplier of 5. So if you have 3 oranges on Monday, that means the other day you multiply that by 5. Basically, it's the ratio between some stuff. Okay, so this 100 is like scaling the private four-year to a percent. So if 100%, if you're paying 100% to go to a private four-year, what percentage of that are you paying to instead go to ODU or CNU? What kind of answer would you expect? Probably something in the double digits, like 15%, 30%. You wouldn't expect it to be 5%. You wouldn't expect it to be more than 100%. the fact that this number right here is bigger than this number here should be true across the entire columns. The fact that the 8893 is bigger than the 3264 should be true across the entire columns. All of these numbers in the first column should be the biggest, all the numbers in the middle should be in the middle, and all the numbers on the right should be the smallest. Now, that's just based on how I set this up, or how they set it up. If you swap all the public and private four-year numbers, then the biggest ones would be on the right, smallest on the left. Okay, so scaling this to 100, the private four-year, that'll be like us saying, all right, well, what percentage are you paying in comparison to a private four-year to go to ODU? Maybe like 20%. What percentage are you paying to go to TCC? Maybe like 10%. Scaling things to 1 is like, okay, for every $1 you spend in a public four-year school, how many dollars do you spend going at a private, if you wanted to go to a private four-year school instead? And you would expect that to be more. Every $1 you spend here is going to be $3 or $4 or $5 or $10 here because of the 9,000 versus 30,000. On the contrary, for every dollar you spend at your ODU, you're going to expect to spend less than $1 for TCC. So these are the things you should be saying or going through with the does it make sense aspect. If I got an answer right here that was 5, it would not make sense because that would say for every dollar I spend at ODU, I would instead be spending $5 at TCC. No, sir, no, ma'am. If it's $1 at ODU, I should be spending, I don't know, 30 cents, 40 cents, 10 cents, 20 cents, somewhere in the cents ballpark. And again, that's for every dollar. So down here, this says for every dollar you pay going to TCC, if you wanted the same education, how many dollars would it cost to go to ODU? Again, $1 at TCC is going to cost you how many dollars instead at ODU? Or if you spend $1 at TCC, how many dollars would you be spending at Virginia Wesleyan? These ones are really awesome for the multiplier effect. For example, let's just say, I'm making this up. Let's say it turned out to be for every $1 you spend at TCC, it's $5. Again, this is wrong. If it was for every $1 you spend at TCC, you would instead spend $5 at ODU. That means that if I spent $100 at TCC, I would instead be spending $500 at ODU. If I spent $1,000 at TCC, that means it would instead cost me $5,000 at ODU. If I spend $10,000 at TCC, it would cost me $50,000 at ODU. So scaling things to 1 is a great way to give us just a multiplying effect. That's what this is alluding to, that will go into greater detail when we have the real answers. So our ultimate goal is to fill out this table completely. We didn't do that last time. We just wanted a couple of the boxes. This time we want everything, the whole shebang. You're not ready for this yet. Let's give us some space. Okay. So fill in the table of values in the ratio table. They tell us it's a ratio table or a proportion table, which is awesome. It means we don't have to prove it. For the greatest accuracy, you should always try to use the original statistics in the first row of numbers in the table. This is what I alluded to earlier with accuracy. So when I get this answer of, say, about 3.5, spoilers alerts, all the plurals, spoiler alerts. When I get about 3.5 here, if I don't have to, I don't want to use that number to find this blank, this blank, this blank, this blank, or this blank. I want to try and only use the 1, 2, 3, 4, 5, 6 numbers they gave us. Maybe you can't, maybe you can, but that's your first effort. Okay, the order of the blanks you tackle these doesn't really matter. I'm going to tackle them in this order. I'm going to label them A, B, C, D, E, and F. Please work. Did that work? It did, okay. So I'm going to try and find A first. Remember, you're trying to draw a box. And I'm not going to actually literally draw the box every single time. It's going to get tedious. This was going to be a guided activity for y'all, but there's only 6 answers and I got a lot of students, so it's okay. I want to go through it together. So we take the 30,000 over the A and set it equal to the 8893 over the 1. Again, this is my box. 3 corners have numbers, 1 has a blank. Can you see that? I hope you can see that. I'm circling around these 4 spots. So we're going 30,094 over A equals 8893 over 1. Remember, there's arguably 16 different ways I can write this proportion with those 4 values and variables and still get the answer right in the end. There's also plenty of ways we can write it wrong. My favorite is top over bottom equals top over bottom. Cross multiply. I'm not going to show every single step. 30,094 times 1 is 30,094 equals 8893 times A. 8893 times A. Divide both sides by the number with the variable. Divide by 8893. And we ultimately get calculator. I don't know why I have to do that sometimes. It's clear. 30,094 divided by 8893. 3.38 blah, 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 blah. Now they nowhere told us how many places to round to. You can choose to round to 2. You can choose to round to 1. It's up to you. Sorry for the little ink over there. I just don't want to remove those. I'm going to round to 1 decimal place for this one. You could certainly round to 2. Because I didn't tell you where to round, you could round to 2. You could round to 3. I'm going to choose 1 for this one. So that's 3. I hate that it does that when I go back to Word. 3.4 is equal to A. So that's a 3.4. Now, again, I could use that number to find a couple other spots, but I'm going to avoid it if I can. Now let's try and find B. Can we imagine ourselves drawing a box around B in some manner? Well, you're not going to be able to do it down here in any way because these are all blanks pretty much. So you're going to have to go above it. So maybe the whole thing. Could you do it this way? You certainly could. If I go around all 6 of these values, I'd be using the 30,000, the A, the 3,200, and the B. But that uses a borrowed number, a rounded number, and I suggested that we try not to do that. So while it does work, you'll get a close answer. It won't be exactly the same as what I'm about to do. So I'm going to draw my box this way. I still have 3 numbers in corners and an unknown. So I'm going to go 8893 over 1 is equal to 3264 over B. Again, this is the box. These 4 right here, all snug next to each other. Cross multiply, you get 8893B equals 1 times anything is the anything, so 3264. Divide both sides by the 8893. To tell us that B is equal to 3264 divided by 8893. And we get 0.367. Now, because this number is not a whole, you might say, well, you rounded the first one to 1 decimal place, so 0.4, and that's okay. It's not bad. But because this number doesn't have any holes to it, I'm going to be very loose in how I round. Even though I rounded the last one to 1 place, I'm going to round this one to 2. Does that mean you have to know to do that? No. You can call that 0.4, but I just feel like this gives it a little more accuracy. And you might say, all right, well, since I rounded that one to 2, maybe you go back and round the previous one and you call this 3.38. Again, that is perfectly fine in the real world. All right, let me try and not use too much space. So that was B. Do these answers make sense? Okay, for every $1 you spend at ODU, that means we would be spending A, $3.4 at Virginia Wesleyan at a private university. I think that makes sense. It's a 3.4 multiplier. So if you spent $1,000 at TCC, that means you'd be spending $3,400 at Virginia Wesleyan. If you spent $10,000 at TCC, you'd be spending $34,000 at Virginia Wesleyan. That's the convenience of scaling to 1. How about B? For every $1 you spend at ODU, you would spend 37 cents at TCC. Again, that makes sense. You should be spending less than what you're spending at ODU. All right, let's try and get C. I'm going to skip drawing a million fake boxes just in the interest of time. But again, try and practice this on your own. After you see these answers, go back and try and replicate them. Don't just listen to me and say, this is how I drew the box. Figure it out on your own. Okay, so this discussion board, this group work is just going to be independent, and I'm not going to ask for the answers because I want every single one of you to do this, not just 6 of you. So C, if we do the box like this, that would be not good because we'd have 2 blanks. We'd be using C and D. So how about this? There we go. the 30,000, the 8,800, the 100, and the C. We're ignoring the A and the 1 row. We're going corners. 30,000, 8,800, 100, and the C. So 30,094 over 100 is equal to 8,893 over C. Cross multiply, you'll get 30,094 times C is equal to 100 times 8,893. Just tack on 2 zeros, 8,89300. Divide both sides by the 30,094. Make sure you're doing your algebra correctly. Again, you are supposed to be experts of algebra at this level, not crazy algebra experts, just the simple stuff. And yes, this is simple stuff. Do your math. So 8893 00 divided by 30094. And we get 29.55. It's got a whole, sum it around it to one decimal, 29.6. So this is your 29.6. So that says for every $100 you spent at Virginia Wesleyan, you're only spending $29.6 at ODU. That's one way you can think of it. But the way I prefer to think about it when you're talking about scaling to 100 is a percentage. So if you're calling the private school 100%, that says that ODU only costs you 29.6% in comparison to Virginia Wesleyan. That's what that says. So because this was 100, that's calling 100% the Virginia Wesleyan type school. This says that ODU type schools would cost 29.6% of that. D will be a similar type answer. And I'm going to draw my box this way. I hope you can see that. Around the 30,000, the 3,200, the 100, and the D. Yes, I could draw it this way using the C and D, but then I'm borrowing a rounded number, which would give slightly different answers. So again, 30,000 over 100 equals the 3,200 over the D. 30,094 over the 100 equals the 3,264 over the D. Cross multiply, 30,094D equals 326400. Divide, I'm going to skip showing all that work and just do it in the calculator. So we get 326400 divided by 30094. And we end up with D equals 10.8. Again, rounding to 1 because of the holes. D equals 10.8. So does it make sense? Well, I hope so. If 100% is the private school, 29.6% is ODU, 10.8% is TCC. So TCC costs 10.8% as much as a private school. Again, if those were the actual numbers, which are not, these are averages. E and F, very similar. To get E, I'm going to draw a box around this whole thing. So the numbers I'll use, the corners are the 30,000, the 3,200, the E box, and the 1. Whoops, I didn't mean to click that. Uh-oh. Uh-oh. Oh, that's just silly. Now they're not going to be in the right place. I'm not erasing that and rewriting it. You know where the boxes are. Sorry about that. My calculator back up. I didn't mean to click something is what had happened there. So the 30,094 over box E equals the 3,264 over the 1. So now we're saying for every dollar we spend at TCC, how many dollars would we be spending at the private school? Cross multiply, we get 30,094 equals 3,264E. Divide both sides by the 3,264. 30,094, oops, went too far. Divided by 3,264. And we get our answer. The E, does that look right? I did this intentionally wrong, believe it or not. 92. So we're saying for every $1 we spend at TCC, we're spending almost 100 at that. That doesn't seem to fit the rest of the bill. I mean, it is bigger, but it seems like we made a mistake somewhere. And it wasn't in the algebra over here. It was in the calculator use. I hit 0 one too many times. So let's try again. 30,094, not 300,094. There we go. divided by 3264. But if you don't pay attention, if you don't ask yourself these questions, you're going to assume it's right because your calculator said it, and you're going to get it wrong. So 9, shouldn't say hate, 9.2, I dislike, equals E. Hate's a strong word. So for every $1 we spend at TCC, we're spending about $9 at the private school. That seems to fit the bill a little more. 3,000 versus 30,000. That's about a multiplier of 10 to go from one to the other. So 1 to 9.2 is a multiplier of about 10. All right, finally, to get F, I'm going to draw my box in this way. And again, you don't have to literally draw the boxes. It's just visualizing them ultimately. 8893, the 3264, the F, and the 1. So 8893 over the F equals the 3264 over the 1. Scaling things to 1 is also awesome in the proportions because it's just 8893 equals 3264 F. Divide by the 3264. Spoilers, I'm going to do this wrong. I'm going to divide wrong. I'm going to do 3264 divided by 8893. And I get 0.367. So that says for every $1 I spend at TCC, I'm spending 37 cents at ODU. That doesn't make sense because ODU is more costly. Oh, I goofed my algebra. Instead of dividing by the 3264, I divided by the 8893. So let's fix that. We asked ourselves if it made sense. We checked our work. We didn't just trust a calculator blindly like so many people of the world. Trusting data blindly, trusting computers blindly. 2.72 or 2.7 since it is a whole, it has a whole number in it. And again, I chose to round in this way. I would never care if I don't tell you how to round in a test. I would not have a preference, but your tests will tell you to round. This is not a test style question where you have to figure out how to round. This is a real life scenario where you just kind of choose the level of accuracy. You could have chosen 2 decimals for all of them. You could have chosen 1 decimal for all of them. You could have gone to 3 decimals. Whole number, a little too much rounding for some of them in my opinion, but you certainly could have. And that of course was F. So does that make sense? For every $1 we spend at TCC, we're spending about 2.7 at ODU. Yeah, I think that makes sense. These things are about a 3 times multiplier. This is about a 3 times multiplier. All right, let's clear our screen. Go off of annotate. Question 6 refers to that multiply thing I was talking about, going from here to here. Multiply by what? So how would you go from here to here, just doing a multiplier and not cross multiplying? Because cross multiplying is one way to solve proportions and to do things, but when you scale to 1, you don't necessarily have to cross multiply and all that jazz. You don't necessarily have to set up a proportion. You can use that, oh, okay, well, we went from 2 apples to 10 apples, that's 5 times as many. So if we have 3 oranges, I'd expect 5 times as many oranges. 3 times 5 is 15. You can use that concept. So question 6, what number do you multiply by? I'm going to put the annotate on for this, to go from the values in the 2nd row to the 3rd row. So we're trying to go from here to here. So multiply by what? Where the numbers we had in place were, this was a 3.4, this was a 9.2, this was a 29.6, I had to write this down, this was a 2.7, 0.37, and 10.8, 10.8. This idea of multiplying by is all centered around the 1. That's your anchor. So we're going from row 2 to row 3, row 2 to row 3. So you find the 1 in row 2, and you find out what value it turns into. It turns into a 29.6. That is your multiplier. This right here is the multiplier, the number that the 1 references to. Now, if I said if we were trying to go from column 2 to column 3, that would not be the multiplier. We'd be going this way from the 1 to the 0.37 instead. So we have to pay attention to what they asked. So we multiply by 29.6 to get row 3 values. So instead of doing all those proportions and stuff to find the 29.6 and the 10.8, check this out. Let me take it off of annotate. pull up my calculator. If you don't trust me, why am I still on annotate? I said off of annotate, you silly goose. So this 3.4, I'm saying if you multiply that by 29.6, you'll get 100. At least close, 3.4 times 29.6. There was rounding involved, so it might not be exact, but that's freaking close to 100. This 0.37, if you multiply it by 29.6, 0.37 times 29.6. 10.95, 10.8, really close, so that's a good quantitative idea. So when we have a 1, it's really nice in terms of the actual application of saying, all right, for every dollar we spend here, this is how much is spent here, this is how much is spent here. But it's also amazing for filling out other parts of a proportion table without cross-multiplying and solving, cross-multiplying and solving. Now, again, are these answers exact? No. Are they good enough in terms of rounding in real world? Yeah, sure. How could we have made them more exact? Have more decimal places. Okay, so what about the other part? How do we go from the third column to the first column? How do we go from the third column to the first column? Well, the third column is this column. There's a 1 in it, which is right here. Back to annotate. So we're starting in the third column and we're going to the first column. So this 1 points to the 9.2, which is that's the multiplier. So that's the second part. So from the third column to the first column, that's what I'm answering now. You would multiply by 9.2. So to have gotten the 3.4 or the 100, if that was a blank, you can just multiply anything in the third column by 9.2 to get the first column. Don't trust me? Oh, I know why. I just figured that out. I got to remember that, why I kept accidentally coming back to annotate. So let's take the 10.8 times 9.2. And again, both of these are rounded values, so it's not going to be exactly 100, but it's close. If you take the 0.37 and multiply by 9.2, won't be exact, but it's pretty close, 3.4. That one's actually really close. And the closeness is going to vary. I'm not going to talk about the reasoning behind it. But yeah, these are just some awesome things that you can use. Scaling to 1 gives us a way to fill out a proportion table quicker because we won't have to set up proportions. We can just use multipliers. Scaling to 1 is also awesome because it enables us to do that. All right, for every 1 here, how many about over there? How many over there? Scaling things to 100, great for percentages. Pardon my cough. What do I have? About 5 minutes. I don't have enough time to finish that one, which sucks. That's where I wanted to do that, but I don't have time. That's frustrating. Okay, so what I'm going to do is I'm going to make a statement. Let's clear my screen. Off of annotate. Back to the Word file. Not that Word file, the other one. Maximize it again. So just kind of a note. You may come back and complete page 6970 together or as a DB discussion board. It shows us writing ratios to 1 or to 100. It takes one of the examples for number 2. It does them in one way, then in number 3, it flips them to make sure that you're paying attention. So instead of going big number to small number, it asks you to go small number to big number. Question 1 we'll skip. It's not that relevant to what we need to do. But it's just questions 2 and 3 really. 2, 3, and 4, excuse me, that we'll do later. And again, I might do it. It might be a discussion board. We'll see. wonder if you can hear me flipping these pages. I'm curious. It makes no sense to start this next section with only 5 minutes. So we're just going to call it a day. I mean, for a pre-recorded lecture, this is pretty good, I hope, finishing out 2.1. So we are done with 2.1. All of the due dates I had earlier are accurate. So 2.1 will be due on the 24th. We will absolutely complete 2.2 next class, so that would then be due a week later on the 26th. Excel, TV loan. I've had one or two of you emailing me questions, which is awesome. You've been asking good questions. I've been giving, quote, in my opinion, good answers. And a good answer for me is I'm not telling you the answer. I'm pushing you in the direction to discover it on your own. And I give really good hints. I don't, if I have someone asking me for 50 hints, I'm not going to answer them all. It's one or two hints, and that's pretty much where I tend to cap it. Remember that you also have the tutoring center. They've got hours of availability. They help with Excel. So that's another good resource as well, and that you have a lot more time available outside of class with them. Don't forget to do this video quiz. Don't earn zeros on quizzes. Do not earn zeros on quizzes. The Excel homework submissions, we've only had one so far, official Excel, because remember the chapter 0 doesn't count. A bit all over the place. Some of you, I had a lot of A's and B's, which was awesome. I also had a decent amount of not A's and B's, significantly far away from A's and B's. And across all my classes, I had a decent amount of no submission at all. You have got to do this Excel homework. It is a big chunk of your grade. Not only is it your Excel homework, it's the project. You'll have test questions that are based on Excel, not a lot of them, but some of them. You're not going to make an A or a B in this class if you don't do Excel. The absolute best you can make is a C, and even that's going to be really tough. Do not think you can skip the Excel assignments. I'm going to start sending emails to you if you are repeatedly not submitting these. I might force you to go to the tutoring sessions because remember, I get to count participation as attendance. So if you're not submitting anything, that means you're absent. All right, so I know that's kind of a bad note to leave things on, but the positive was lots of good submissions. We still have lots of opportunity for those of you who did not do well on this one to make it up. Remember, we're going to have around 10 Excel, so if you missed one, a single zero is not going to affect that average that much. But if you miss 7 of them, oh, it will. So please stay on top of things. Please work hard. You've got to put an effort in this. Remember, at least 6 hours of studying, homework, working on Excel, working on quizzes, whatever. Reading ahead, reading old notes, organizing things. That's the expectations of you. Some of you will need 9 hours. Some of you maybe only 3 or 4 hours, but the expectation is at least 6. If you're not putting in the 6 hours and you're not doing things or you're making D's and F's, that's on you for not trying. You've got to try. You've got to take hold of your own destiny, so to speak, not blame others. But in the effort, and some of you, maybe you just need to make a schedule, do time blocking, say, all right, every Monday from 3 to 5, I'm going to work on homework for Math 154, and then every Tuesday from 9 to 11, I don't know, AM or PM, whatever. You don't have to block 2 hours at a time, block an hour. If you are blocking 2 hours, take a 5 to 10 minute breather, take a break. Don't work yourself rigorously just back to back. Work an hour, take 5 minutes, work an hour, take 5 minutes. Because if you overdo it, if you overwork yourself, things don't absorb. All right, enough rambling. We'll call it a day. Have a good one. I hope you watch this. I hope you pay attention. I hope you learned something. I will be back to regular class on Tuesday, the 22nd. Take care.